Hi everybody, and thank you for joining us today for our webinar, The Truth Behind Fiberglass Health and Safety. My name is Kim Melton, and I'm going to be the moderator and co-host for today's presentation. Joining me also is Bruce Ray, our Associate General Counsel from Johns Manville. But before we dive into introductions, I'd like to go over a few logistics. First is that we'll conclude the webinar with a live Q&A session. So if you have any questions throughout the presentation, you can actually submit those via the Q&A box on the right side of your screen. If you don't see that box, look in the top right corner, you'll see a Q&A. And if you click on that, it'll open a dialog box that you can use to submit your questions. Also, we're frequently asked whether or not we post these webinars or we send these presentations out upon their conclusion. And we actually don't send out the presentation itself, but we do post a recording of it online. So you can watch that at your leisure or even share it with your colleagues, but this ensures that you get the presentation within its full context. Now, this is part of how we deliver the JAM experience to you. And at Johns Manville, the JAM experience it's part of our culture, and it's based on 4 pillars: people, passion, perform, and protect. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. Now, we're continuously striving to improve these webinars. So if you have any comments or suggestions as to how we can better accomplish this, or maybe you feel like we've even missed the mark today, we'll be sending out a survey after this webinar is complete, and we'd encourage you and even ask you to fill that out. We use your feedback to improve our webinars and provide the information that has the most value to you. So on that note, let's get to introductions, and I'll hand it to Bruce to introduce himself.
Thank you, Kim. This is Bruce Ray, and I serve as Associate General Counsel for Johns Manville. I'm also Director of Governmental and Regulatory Affairs. I've been at Johns Manville. I'm in my 28th year. I started in 1990, and I've been focusing on fiberglass hazard and safety and health issues since the early 1990s. Prior to Johns Manville, I worked at US EPA, and my focus there was primarily in the Superfund program, where I did work on hazards and risk assessment, so I'm well acquainted with the subject matter and the legal issues.
All right, and as I said, I'm Kim Melton, and I'm the Technical Content Strategist for Performance Materials. And I've been at Johns Manville for 4 years, and in that time, I've been responsible for helping to create and aggregate the fiberglass health and safety content, like this webinar you're attending today. I'm also the Technical Content Manager for our HVAC, mechanical, and industrial businesses. So we have a blog, we have webinars, we have data sheets, any of the content you're finding online for those businesses. It's my role and my responsibility to help get them to you and make sure they're accurate, timely, and helpful. So with that, we're going to dive into some of the basics, and we'll start with a quick vocabulary lesson. Bruce and I are going to be talking about various content in the industry, and we might be using vernacular that you're not really familiar with. So I wanted to go through some of the key things that we're going to talk about and help define what they are right out of the gate. So the first is a biosoluble fiber. Now, this is a fiber that's capable of being dissolved in the lung, also known as in vivo, and that's after it's been inhaled at a fast enough rate that no health hazard is presented to the body, save for maybe temporary mechanical irritation. Now, at the opposite end of the spectrum, you have what's called a biopersistent fiber. Now, while this can typically be dissolved in the lung, it's at a much slower rate, and it's much more likely to cause potential hazards to the person who's inhaled it or the being that has inhaled it. Now, when we talk about solubility, we actually measure that in K-dis, and that's a dissolution constant. And it's an in vitro measurement of a glass fiber that's how quickly it can be dissolved in simulated lung fluid, and we use the K-dis to predict in vivo biosolubility. Now, what actually dissolves the cell is called a macrophage, and this is a scavenger cell in the lung that ingests inhaled foreign particles and removes them from the body. Now, we also have what are called special purpose fibers. These are glass fibers that are not used for insulation applications, but actually have special functions like filtration or battery separators, and they comprise no more than 1% of all glass fibers manufactured. So the insulation fibers we're discussing today are not special purpose fibers. Now, there are 2 authoritative scientific governing bodies that maintain the official list of carcinogens. IARC is the International Agency for Research on Cancer, and the NTP is the U.S. National Toxicology Program, and both of these are responsible for maintaining these lists of specific carcinogens that you might find not only pertaining to fiberglass, but other carcinogens throughout any sort of produced material. With that, let's talk a little bit about what's with Fiber-Phobia and where it's come from. Now, first and foremost, it's a lack of knowledge around the science. So there have been decades worth of research, and in fact, fiberglass is one of the most studied materials out there. And the initial research was actually formed around ill-designed studies, and as a result, there was a lot of misinformation out there about how it actually interacts with lung tissue and with the human body, and as a result, it's created a bit of hearsay around what's actually going on. Now, in addition to that, there's a misunderstanding of hazard classifications. Now, it would be convenient if these governing authoritative bodies actually had all of the same content and all the same language and criteria for defining what a hazard is, but they don't. And as a result, it can actually cause some confusion within the industry. And finally, we actually find that there are quite a few false and deceptive claims by competitors. And what we mean by this is you might see things like fiber-free, which have an inherent implication that there's actually something wrong with fiberglass, and that's actually just simply not the case. So where are we today with our science, hazards, and regulation? First, simply put, this is what you need to take away, and that is insulation glass fibers are not classified as a carcinogen. Now, this is recognized by national and international authoritative scientific and regulatory bodies based on science that was developed in the 90s and is still used today. Now, because of this, cancer warning labels are not required by law on any of our insulation fiberglass. And in addition to that, science has found that indoor air exposure to glass fibers is actually very, very low, both in manufacturing and residential and commercial applications. We'll get into the details on each of these here in just a minute. And with that, I'm going to hand it back to Bruce.
Thank you, Kim. In order for us to really understand where we are, we have to put the present situation in some context and go through some of the regulatory and some of the research history. Now, there were some initial studies that were done way back in the 1970s through the 1980s by Friedrich Pott and some of his research team. And what they did is they would take various glass fibers and they would surgically implant those fibers in the rat peritoneum, which is the membrane that essentially forms the lining around the abdominal cavity. These studies were called intraperitoneal implantation, or IP studies, and not surprisingly, when they would examine these rats that were implanted with glass fibers, they did find some tumors. The problem with this approach is that it is not really a relevant route of exposure. What you're really worried about are fibers being inhaled into the lung. The problem is that when the International Agency for Research on Cancer, IARC, was looking at these rat studies in the late 1980s, they basically looked at the science that was out there, and it was mostly these IP studies. And so their mission was to classify glass fibers into their hazard classification scheme. And as you can see there, those are the various groups, hazard groups that IARC has. And so what happened was IARC looked at those IP studies, and they found that they decided that those were sufficient evidence in animals that glass fibers might cause cancer, and so they classified them as a Group 2B possible carcinogen. As you can see there, the way IARC classifies the hazards for materials, they look at the human evidence and they look at the animal evidence. The human evidence has always been inadequate, but they thought at that time, back in 1987, that those early IP studies provided sufficient data in animals. And the reason why they looked at the IP studies and relied on them for the Group 2B classification was that they had found that there was really no well-designed animal inhalation study at that time. Now, the outcome of that Class 2B classification was pretty important. Here in the United States, the OSHA Hazard Communication Standard recognizes IARC as an authoritative scientific body, which meant that basically after IARC made its 2B classification for glass fibers, well, we had to put the possible cancer hazard warning label on all of our fiberglass products here in the United States. Similarly, a little bit later than IARC in 1994, the National Toxicology Program also adopted the IARC classification, except their terminology was a little bit different. Instead of saying it was a possible cancer hazard, they said it was reasonably anticipated to be a carcinogen. So that's why years ago we used to have cancer warning labels on the fiberglass products. Now, naturally, when IARC said that there were no well-designed animal inhalation studies, the industry thought, well, it would be a great idea to develop those new animal inhalation studies. And so the industry spent a lot of time consulting with experts in academia and government, et cetera, and came up with protocols on how best to expose lab animals to glass fibers. Once the protocols were developed and approved, we undertook long-term animal inhalation studies at the RCC, which is a company in Geneva, Switzerland. 2 species of test animals were used, and we did test 3 kinds of fibers: insulation fiberglass, the special purpose fibers, and then it was also very important to have asbestos be tested as a control. We did a 24-month exposure for the test animals, and we would do interim and final analysis, and we would look, of course, not only for fibrosis and tumors in the lungs of the test animals, but we'd also do fiber count in the lungs to make sure that those test animals were getting a sufficient amount of fibers inhaled deeply into their lungs so that we could really get a good indication of what the hazards might be. The results of the long-term studies showed that for the asbestos controls, we did have, of course, tumor proliferation. That was very important because it showed that, again, we were getting the fibers deeply inhaled by the test animals. For the special purpose fibers, those non-insulation fibers, we did come back with some test animals that had some fibrosis and tumors, but the important thing that came out of those studies in the early 1990s was that for the insulation glass fibers, there were no fibrosis and no tumors. A couple of observations that we made, which were a little bit counterintuitive, that when we were doing some of the fiber counts in the lungs, we would measure them first within just a couple of days after the exposure, and then, of course, we would measure them later on. And it was interesting to see that the number of fibers in the lungs of the test animals were actually increasing over time. It was an unexpected result, but it turned out to be one of the keys to the mechanism of what we call fiber-based carcinogenesis. Now, the conclusions from the animal studies on this slide are very important. If you can take away just one slide from a technical standpoint from today's webinar, this would be the slide to remember. As a result of the animal studies, it was determined and confirmed that potential cancer hazard from fibers is controlled by the 3 Ds: dose, dimension, and durability. The dose is really the ability of the fiber to be deeply inhaled. And one of the things that we did confirm again is that if you have a fiber that is thin enough, it will actually behave in the lung like a particle, and it will be deeply respirable. The dimension of the fibers turned out to be very important as well, because if you have a fiber that is longer than one of those macrophage scavenger cells is wide, that is about 20 microns, you may have trouble getting those durable fibers removed from the lung. And then, of course, durability, and the studies confirmed that fiber durability is the hallmark of possible cancer hazard, because if you have a fiber that can persist in the lung, it will cause chronic inflammation, which will cause cell repair, some cell proliferation, which can lead to fibrosis and ultimately to tumors. We did find and confirm that the insulation glass fibers are biosoluble, and this is based not only on their chemistry but on their morphology as well. Quickly, just want to talk a bit about some of the cellular interaction with fibers. And if you've got a long fiber, that is a fiber that is longer than a scavenger cell is wide, you can see that there's different kinds of dissolution of that fiber that can take place in the lung. You have either congruent dissolution, which means the fiber itself stays intact and just kind of dissolves to nothing, or you can have incongruent dissolution. And this incongruent dissolution is a mechanism that was found in the animal studies, to where one fiber, because there's a transverse breakage by macrophages, can actually turn into multiple fibers. And then you see, once we have the fibers are broken up, you have what's called macrophage translocation, and you can basically have these scavenger cells essentially engulf the fiber or the fiber parts, the breakage, and essentially take them out of the lung via what's called a mucociliary escalator. Now, we put together a brief animation here to show what happens when glass fibers are deeply inhaled in the lung and when macrophages are there, the scavenger cells trying to remove them. If you have a durable fiber, what happens is the macrophage tries to engulf the fiber. And you can see the fiber here is much longer than the macrophage is wide. Because the fiber is durable and it cannot be broken up by the macrophage will actually die and it will leak out low pH enzymes. Those low pH enzymes will cause some of that long-term inflammation, the cell proliferation, possibly fibers, and possibly fibrosis and tumors. In contrast, if you have a biosoluble fiber, the macrophage is able to release its enzymes and dissolve that fiber, break it up into smaller parts, engulf it, and then take it out of the lung. So as we said, in the early 1990s, we had this new animal inhalation science that was developed by the industry, and we had the long-term animal inhalation studies. It was also very important for us to look at the human data. And by human data, I don't mean, of course, exposing people to glass fibers. What human data refers to is epidemiology study that has been underway for fiberglass workers for decades. And just as a reminder, what epidemiology means is that what you do is you identify an exposed population of fiberglass manufacturing workers. And after they pass, you do a comprehensive review of death certificates and you look for the cause of death. Then you look at, you basically compare your exposed population to an unexposed population, and then you look if there's any difference in either a rate of respiratory system cancer or non-malignant respiratory disease. So you're essentially comparing the exposed factory workers with the unexposed, potentially general population, and then you're seeing if there's any differences there. Now, the human epidemiology study was most recently updated in a comprehensive way in 2001, and this is done by Dr. Gary Marsh, who was the director. He was at the University of Pittsburgh, and he was actually in the Graduate School of Public Health there, and one of the top professors around epidemiology. It's important to understand the statistical power and robustness of this study. It includes nearly 1 million person-years of exposure between right after World War II going up into the early 1990s. The results of the study were that respiratory system cancer rates were not higher in the exposed population, especially after controlling for confounders like smoking. Importantly, the duration of exposure, as well as the cumulative exposure to respirable fiberglass, was not associated with any increase in respiratory system cancer. And then in addition, too, we found no apparent trend with increasing exposure. It's important to note that the epidemiology study looked at fiberglass manufacturing workers in those plants that made both the soluble insulation fibers, but also plants that made the more durable special purpose fibers. More recently, we had Dr. Marsh and his team do a kind of a decade update, so that in 2009, they looked at all of the science that was published since their update in 2001 to see whether or not there was any new information that might call into question the conclusions of their 2001 update study. And they did conclude that the 2001 study update, all the conclusions are still valid, and as a matter of fact, this 2009 update was most recently accepted by the NTP's expert panel and the Board of Scientific Counselors. So, where were we as of 2001? We had some important conclusions from both study types. We had new animal science that importantly, very critically, confirmed the role of fiber durability in cancer hazard. and it demonstrated that the insulation glass fibers are sufficiently biosoluble that there's really no cancer hazard presented. We also, in addition to that new animal science, we had updated human Epi study science there. Again, as I said, over 1 million person years of exposure, accounting for nearly 50 years of duration of exposure. And that really confirmed that the rates of respiratory system cancer in fiberglass workers were no higher than the unexposed general population. So the next step after that, what happened? The matter was based on the new science. IARC gave a notice that it was going to re-examine its 1987 classification of fiberglass as 2B possible carcinogen. And because we had the new animal science, they moved, you can see there, from the 2B possible carcinogen status over to the class 3, not unclassifiable as to carcinogenicity. And you can see there that box where the arrow is pointing. That's what IARC did in its 2001 action. They still considered the human evidence to be inadequate based on Dr. Marsh's Epi Study update. But instead of the animal science being considered sufficient, now it was really considered only limited, and so they moved they downgraded the insulation glass fibers out of the possible carcinogens category. Importantly, however, the special purpose fibers were kept at group 2B. And fortunately, we had the National Toxicology Program recognize this new science, both the animal science as well as the human epi. And because recall, as I said earlier, in 1994, the NTP listed glass wool as reasonably anticipated to be a carcinogen. Again, that was based on the early IP studies and IARC's 1987 classification. But importantly, in 2001, the NTP in its 12th update to the report on carcinogens reviewed all this new science and removed from their list of reasonably anticipated carcinogens those glass fibers that have been successfully tested in animals. Now, if you look at the National Toxicology Program's new substance profile for glass wool, and this is what Kim was talking about, where there is some confusion. IARC has the classification scheme that we showed a couple of slides ago, the table. The NTP takes a bit of a different approach, certainly for glass wool fibers, they took a very different approach. Essentially, what NTP says is that glass wool fibers, they're presumptively still reasonably anticipated to be carcinogens unless they are specifically exonerated by animal tests, such as the RCC tests that we described in some detail just moments ago. And what they're saying is that essentially they looked at all the studies and they said, look, all of this evidence indicates only certain fibers within glass wool, and specifically those fibers that are biopersistent, are reasonably anticipated to be carcinogens. And this is a critical distinction because you would draw that between special purpose fibers and insulation glass fibers. All the insulation as if we didn't have enough with having to take the IARC 2001 reclassification to the National Toxicology Program. We also had to make sure that the regulators in California that administer the Prop 65 program also recognized that these biosoluble insulation fibers did not present a cancer hazard. And so in 2011, California also revised its listing, its Proposition 65 listing of glass fibers to include only the respirable durable fibers. So with that, I'm going to pass it over to Kim, who's going to talk a little bit about the exposure levels to glass fibers.
Great, thank you, Bruce. So naturally, people wonder, are these fibers actually in the air? Is it something I actually need to be concerned about? And what happened was NAIMA decided to actually explore that. And the reason for that is because OSHA decided to establish a worker protection and hazard exposure limit specifically around glass fibers. And NAIMA, rather than being reactive, decided to be proactive, and they approached OSHA and said, what information do you need to feel like you can effectively establish this worker protection and hazard exposure limit? And basically, OSHA said that there's a pretty significant ignorance around the actual exposure levels in manufacturing and in commercial and residential applications. So NAIMA set out to create a database of exposure levels to determine exactly how much people are being exposed to insulation glass fibers in various settings. Now, they have a very robust database. As of today, there are 16,400 data points from manufacturing, installation, retrofit, removal, and fabrication. And again, like I said, the reason they chose to set up this database was so that OSHA could establish worker protection around people who are actually working with fiberglass. Now, the findings actually reported fairly low exposure, significantly less than 1 fiber per cubic centimeter. Now, what's really relevant about this is that the exposure, as Bruce just discussed in the human epidemiology studies, you had these people who were working with fiberglass insulation for years, decades, 1 million person years, and as a result, they, the outcome of the study showed that there wasn't a correlation. And we think that a strong supporter of this is that, what NAIMA found is that in these manufacturing facilities, you're looking at less than 1 fiber per cubic centimeter of exposure. Now, that is the OSHA-NAIMA Voluntary Permissible Exposure Limit, or PEL. And what that is if you're working in an environment or an application where you're going to be exposed to a volume of fibers or a concentration of fibers that is greater than 1 fiber per cubic centimeter, you may want to consider wearing personal protection equipment over like a NIOSH N95 dust mask. So what do the actual numbers look like? Well, NAIMA found that the mean exposure levels for every insulation industry sector are below 0.4 fibers per cubic centimeter. Medians are all below 0.25. Now, notably here, even in the 95th percentile of the highest exposure levels, they're still well below the 1 fiber per cubic centimeter voluntary permissible exposure limit. So that leads us to what are people being exposed to in commercial and residential indoor environments. This was a pretty interesting study. So what the researchers did is they counted and they speciated the fibers using both optical and electron microscopy. And the reason they did this is they wanted to determine exactly what kind of fibers are in the air. And what they found is that 97% of the fibers that are respirable were actually organic in nature, like carpets or drapes, etc. And that of all of the fibers, organic and inorganic, only 0.008 respirable fibers per cubic centimeter were present, and there was a maximum of 0.029. Now, of those 0.008 respirable fibers, there were less than 0.0001 fibers per cubic centimeter. Now, what's pretty significant here is that there were 51 residential samples, 154 commercial samples, and of all of those samples, 205, inorganic fibers were only present in 2 of the samples. Now, when we look at the outdoor environment, as you might find in near a manufacturing facility, science found that there was generally, the concentration of fibers were really low and generally the same as the rural background surrounding it. Now, all of this comes together to demonstrate that there isn't a large number or a significant exposure of insulation glass fibers that people are encountering both in manufacturing and professional jobs that are working with fiberglass, as well as what you might encounter in your everyday office or house environment. You're just not seeing a lot of fibers in general, and you're certainly not seeing a number of inorganic fibers like fiberglass. And Bruce is going to discuss, Johns Manville takes fiberglass and the safety of what we're doing very seriously, and Bruce is going to discuss exactly what our stance is on that.
Thanks, Kim. I want to take us back several decades that when the Johns Manville Fiberglass Product Stewardship Program was put in place. And very importantly, at that time, in the late 80s, 1990, Johns Manville committed to several issues around fiberglass hazard and communication. First, they said, we're going to investigate the hazards of these glass fibers, and They said that they were going to communicate around the product hazards fully and on a timely basis with all employees. And our president back then, basically the shorthand way that he would communicate our product stewardship program was that, look, we're going to look and see if there's problems, and we're going to tell you what we know as soon as we know.
NAIMA also actually supported that stance, and they partnered with OSHA to create the Health and Safety Partnership Program, and they're equally as committed to ensuring that people working with fiberglass and within the industry are safe and using safe practices. So as a result, they took the stance of they wanted to enhance hazard communication and education. So they wanted people to know exactly what they were working with. Now they also maintain, and to this day maintain, the comprehensive exposure database that I already discussed with the 16,400 data points. And they established a voluntary permissible exposure limit, as we also already discussed, with the 1 fiber per cubic cc, and developed PPE recommendations around that, like using the dust mask you see here, when exposure levels are greater than 1 fiber per cubic centimeter. Notably, this really only applies in applications where you've got a lot of loose fibers in the air like you would in a blowing wool installation. In most other applications using insulation fiberglass, you're not encountering that volume of loose fibers exposed in the air. So what might people wonder about respiratory protection issues and why you need it at all with insulation glass fibers or biosoluble? It's really to address temporary mechanical irritation. So as you know, fiberglass can be itchy, it can be uncomfortable on your skin. Similarly, when inhaled, it's a temporary mechanical irritation. Recent analysis actually confirmed that it's mechanical and it's not an allergenic respiratory reaction. So your body doesn't have an immune response where it's actually attacking and having this allergic response to it. And even durable glass fibers were found to be non-allergenic. So what can we expect for the future of fiberglass testing? It's pretty interesting where things are moving, and trends are actually moving away from the animal testing, which has been pretty profound because a lot of times the NTP specifically has required this animal testing to exonerate fibers from their assumed carcinogen list. Now, the EU is definitely moving in that direction, and we're actually finding that the NTP is seeming to follow suit, and that's what we expect to happen. As a result, science and research is moving more toward the KDIS in vitro testing on new glass fibers. So what happens here is that fibers are placed in a simulated lung fluid, like Gamble solution, and their mass loss over a specific time period is measured. Now, when they've established that this threshold of 100 is generally the KDIS that's required for a fiber to be biosoluble. All fibers that were tested in animals that had a KDIS of greater than 100 were biosoluble, and this is notable enough that it's been endorsed by the NTP expert panel and is approved by them, and which is why NTP is stepping in with the EU to as we think will happen, as they are indicating will follow suit. So the takeaways from today. I know we kind of ran through a lot of information and fairly quickly, but here are the final conclusions. So of the three slides, that one that we started with, then dose, durability, and dimension, and then the final conclusions here is fiberglass is the most tested insulation available. It's been thoroughly tested, reviewed, vetted. We want to make sure that the materials we produce, and the industry wants to make sure that the materials that are used do not present a cancer hazard, and that's been confirmed repeatedly through a number of different avenues in terms of research and science. As a result, insulation glass fibers pose no cancer hazard. Now, on that note, fiberglass is safe to manufacture and use when common sense precautions are taken to prevent temporary mechanical irritation. And one thing that's important to note is that even though other insulations may be assumed to be safe, frequently this is largely because they haven't been tested. So fiberglass has undergone these tests, but it doesn't necessarily mean that an untested insulation that isn't on maybe the carcinogen list has been tested or has been proven or has been exonerated. It may simply have never been tested. So if you're looking for additional resources on this or other information like this, we do have a wealth of information out there available to you, and we have it on the source. Now what the source is it hosts, it's basically a library of all of the content we have available to you to help walk you through this sort of stuff. So we have training, and this is at Johns Manville Academy, and you can access it through the source. And this covers everything from health and safety of fiberglass to how to install HVAC and mechanical insulation. We also have a specification section where you can compare product specifications side by side, where you can get the, the NRC values and thermal performance, et cetera, all right there in one location. We have a blog, and we post this on a monthly basis. We not only write the content, but we also collect content from other resources in the industry so that you're getting a full, well-rounded perspective of what's out there. And we also post our webinars. This is where we'll post this webinar today, is right there on the source. And then we do have a tool section on there where you can get what we had listed earlier, like the NAIMA 3E Plus program that you can use to establish the thickness of insulation you need of Johns Manville insulation specifically for your application based off of your application requirements. In addition to the source, we also have the OEM Engineering Portal, and this is similar to the source in that it's library of information for you. So it's where you're going to find specifications, information about sustainability, tools like the 3E Plus tool, and again, relevant webinars to the OEM industry. And we will have a certificate of completion, and that's going to be sent to you guys out by Friday. So I realize we moved through this fairly quickly today, and so let's, with that, get into some questions. Bruce, our first question is, how long does it typically take for macrophages to break up longer biopersistent fibers?
The special purpose, the durable fibers such as special purpose fibers are less soluble in the lung. They persist longer in the lung. How much longer they persist is largely a function of the chemistry of the fiber. And we know from quite a few studies that have been done that you can look at the chemistry of a fiber and then predict not only what its K-dis in vitro solubility will be, but also what its durability in vivo would be. In other words, you can look at the chemistry, and then you can estimate how long that, based on that chemistry, that fiber would persist in the lung of a test animal.
And Bruce, there's one question here that says 2001 or 2011, and I know right around both of those time periods there was some change in classifications. Can you speak to that?
Sure. 2001 was the reclassification done by IARC, the International Agency for Research on Cancer. In 2001, IARC looked at all of the new animal studies that were done, looked at the updated human Epi study, and then they removed insulation fiberglass from the list of Group 2B possible carcinogens. Now, it took quite a while for that IARC reclassification to be recognized in the United States. It took 10 years, actually, and that's the 2011 date that the National Toxicology Program then effectively removed soluble insulation fibers or soluble glass fibers that had been successfully tested in animals from their list of compounds reasonably anticipated to be a carcinogen. So just to summarize, the 2001 was the IARC reclassification, and the 2011 was the NTP reclassification. Great,
thank you. This next one I can handle, and that is, are they still testing on animals? And as I said earlier, yes, they are. And as the NTP currently requires, if an insulation glass fiber or if a glass fiber is going to be exonerated, it has to have passed the animal testing that was already developed. However, as we are seeing a trend moving away from the animal testing toward the K-dis biosolubility of a fiber. Now, the EU is definitely moving in that direction. We're seeing some trend toward the NTP probably moving in that direction. Whether or not it has, it will officially do that remains to be seen. And another question just popped up. What about other kinds of fibers?
One of the most important conclusions of the new animal science that was developed in the 1990s was that it was general in nature. So that doesn't matter whether you're considering a glass fiber or some sort of or cellulosic fiber or some of the new nanotube type fibers that are under development. It's the same analysis that you go through to understand whether that fiber might present a possible cancer hazard. You look at the 3Ds, dose, dimension, and durability. And if you've got, some new carbon nanotube that is very, very thin, very long, deeply respirable, the hazard of that fiber is going to be related to the durability of that fiber in the lung.
All right, and the next question is, how do we know that fibers tested years ago are the same fibers that are in use today?
Yeah, that's an important issue. It's a good question. Fortunately, as I said, for a lot of these fibers, it's the chemistry that really determines whether or not they're going to be biosoluble. And fortunately, from a manufacturing standpoint, honestly, the chemistry of the glass fibers has to be very, very stable over time for us to produce a consistently high-quality product. So what we do is, when we look at the chemistry of the fibers that were tested back in the 1990s, and then we compare them to the chemistry of the fibers that we're making now. If that chemistry is the same, I think we can certainly assume that the hazard or the lack of hazard is going to be the same. If there are any changes in the chemistry between the fiber that we tested years ago and the fiber that we're making now, we look to see whether or not, we look to see really the nature or the amount of the chemistry changes. And there are chemical formulas that you can use to determine whether or not slight changes in chemistry have any impact on the durability of the fiber and the hazard of the fiber. And so we follow some standards out of the EU. They're called the USEB standards that are based on a fairly significant body of peer-reviewed journal articles that basically tell you how much you can change the chemistry of your fiber and have it not affect the durability of the fiber, so that you would have to retest it. And we have, Johns Manville has, when we have developed new fiber formulations that are outside of those USEB requirements, what we will do is we will go ahead and retest those fibers, not only in vitro, but we'll actually do new animal studies on those newly developed fibers.
Great, thank you, Bruce. Next question is, do you have a short written summary that we can provide to clients about safety? And yes, we do. We actually have a variety of blogs online, and once we post this webinar online, we'll send you an email with links to the content that you can have that can actually help further your education, and specifically these blogs that you could send to clients to get this kind of information. So the next question we have is, acoustical duct liner, is there any concern using this?
No, short answer. And a couple of reasons, again, has to do with the fibers that are used are biosoluble. And in addition, we have, the duct liners have a coated surface that makes sure that even if at high velocities through the system, that it helps to prevent any fiber shedding. And in addition, we know that certainly for like the line acoustic JM products, that coating of the inside of the duct is treated with an EPA-approved antimicrobial agent to protect that product from intrusion by mold and fungus, so that what you want to do is preclude any mold from growing on that surface that would penetrate that surface and possibly release any fibers. So I'd say no, it's just not an issue.
Great. Anything specifically about safety of internal duct lining? JM offered a letter of indemnity re glass fibers as related to a lining of a number of years ago. Is anything like that still offered? We can still issue what we call the Fiberglass Health Indemnity Agreement. And I think we do that on a case-by-case basis. But yes, we still do that where it's important. And if anything, the science is so settled now that we don't feel ill at ease in issuing that indemnity. So I would ask to, if you're interested in that, contact Kim perhaps initially, and then we can look and see what we need to do on that. Yeah, absolutely. Has mineral wool been tested to similar standards as fiberglass insulation?
Yes, mineral wool was tested in animals in those, long-term animal inhalation studies in the 1990s. So yes, mineral wool has also been successfully tested in animals and shown that it is sufficiently biosoluble that it does not present a cancer hazard.
Great. One thing I did want to add about the letter of indemnity, you can actually contact your local MDM, and they'll be able to coordinate all of that for you. So the next question, this is one we haven't gotten before, and I don't know if we can really speak to it, but that is, can the fibers be a carrier of other airborne contaminants or pollutants?
Not to my knowledge. I've never heard of that. Keep in mind that the glass fibers are chemically inert. They simply really don't react with, other things in the general environment, and it is possible dirt particles could be on insulation fibers, but I've never heard of that, and I don't think that it's an issue.
Okay. Have all JM products been tested?
Certainly all of the JM fiberglass products have been tested, and especially so in a way that we would understand the dose dimension and the durability of the products. And again, we look at the chemistry, the in vitro solubility, the in vivo solubility to determine and really confirm that all of the JM insulation glass fibers do not present a possible cancer hazard by inhalation.
Okay, that wraps up our questions for today. As I mentioned at the beginning of the webinar, you will receive a survey immediately following, and we'd appreciate it if you take a little time to offer your feedback. Additionally, if you have any questions that you were unable to ask, you can submit them via the survey, and we'll respond to you directly via email. So please keep an eye on your inbox for your certificate of completion, as well as the follow-up email that we'll send with additional resources and the recording of this webinar. Thank you very much for your time today, and we hope you enjoyed it and it was informative for you. Have a great rest of your week.